Good afternoon, everyone. Thanks for joining us today. My name is Mark Dirks, and on behalf of Choice and ACRL, I would love to welcome you to our program today, which is Mission Possible, Scaling Up Scholarly Communication with Smart Harvesting AI, a presentation that is supported by Libris, a ProQuest company. Today's discussion is one in a series of sponsored webinars from Choice and ACRL that addresses new ideas, developments, and products of interest to the academic library community. Before we get started, I'd like to point out just a couple of features of the webinar software. For those of you joining us today as attendees, please know that you are automatically muted and your cameras should be disabled, at least in this webinar setting. So don't worry about generating noise or feedback or that sort of thing. That should be all taken care of. Of course, in the main area of the screen, you can follow along with our presentation materials today. And I would also note that we are using the Q&A feature, which will be the primary way for you to engage with our speakers. Please use that to ask any questions that you have. I would also note that the audience for our presentation today is pretty large. So if we don't have enough time to get to all of the questions that come in, we apologize for that. We'll do our best, but our time is rather limited. But that said, please do drop your questions into that Q&A module as they occur to you. And at the end of the presentation, we'll take some time to get to as many as we can. I would also note that there is closed captioning available for today's session. To toggle those captions on or off, please use the CC button on the bottom right corner of your screen. And also note that we are recording today's program and that everyone who registered should receive a follow-up email with a link to that archived version. Our speakers today are Jeff Horan, Director of Research Information Solutions at Libris, and Dr. Sarah Branch, Research Solutions Specialist, also at Libris. And with that, we are ready to get started. So I will turn the presentation over to Jeff.
Thank you, everybody, for joining. I'm Jeff Horn, been at Libris, working with libraries and research offices in scaling up their scholarly communications and utilizing our smart harvesting AI. And that's what we're here to talk about today with me, colleague Sarah Branch, PhD, from our research team. So looking at our agenda for the day, we're going to look at the typical challenges in scholarly communications management, introduce you to smart harvesting, and talk about some general applications of AI in terms of finding publications. Present the user experience, give a demonstration so you can get a live view. So not just theoretical today, getting into the practical. Look at key benefits and use cases. So once I've done this work, gathered this data, what can I do with it? Look at some real world customer examples, and we should have ample time left for Q&A. So please do send the questions in the Q&A function in the webinar here, and also upvote ones that you're interested in. So when we engage with universities, what we see out there are university business systems that were selected by different offices around campus that had different operational goals in mind. Maybe they were selected independently. Maybe they were selected at vastly different points in time, and there's some legacy technical debt there. But there's often a jumble between the systems in terms of faculty activity reporting, research showcasing and putting profiles out there, an institutional repository, research information management system, and other kinds of information tools. So the data challenges break down among institutional lines, basically as we see here. We know that provost offices tend to have faculty activity reporting solutions, and the provost enforces the mandatory data entry, and that means that the entries in that database are going to be around 100% complete. But they typically have no or poor persistent identifiers in the data. So poor metadata, poor interlinking with the rest of the scholarly communications ecosystem, in terms of ability to find a free to read version or analyze the citation metrics. And then libraries put up the institutional repository, and that's usually an optional deposit model. So you're going to expect lower completeness to be achieved in that kind of system because it is optional. So it's the researchers most interested in promoting their work, but not everybody who the provost could twist the arm of. But the flip side is you get excellent metadata and interlinking with the rest of the scholarly communications ecosystem and the full text of the articles. And then the research office tends to have an expert finder system, at least in North America, a bit more common in Europe and other parts of the world that follow national assessment models. You'll see current research information systems or CRIS systems. But in general, the same applies here. And you'll see automated harvesting methods being used because the provost already twisted everybody's arm to manually enter the data. But you'll achieve a lower percentage retrieval rate via this method, and then you'll end up with good interlinking with the rest of the data that's out there in the universe, but probably not as good as you would observe in a repository. So our question is, can we use technology to achieve a better completeness quality trade-off? So could we tap into data that's 100% complete and potentially increase the quality of the metadata? And can we offset some of that workload with automated harvesting? So that's the goal. We want to get to a profile that's comprehensive, up-to-date, interconnected, contains all of that faculty information. So the way we see building it up, working the smartest way possible is by these 3 steps. So smart migration, so taking what you already know about researchers at your institution and have captured in databases and bringing that over. Then smart expansion, so enriching the assets by bouncing it off of a database that has authoritative, persistent identifiers and links to things like free to read versions. And then the main topic today is to cap off that completeness and complete the profiles and keep them up to date over time without people having to become involved again and again and avoiding some of that manual data entry. So the goal here is to harvest via machine learning algorithms and capture that data into the repository. And where we go for that is our central discovery database, where we have 4.5 billion plus records coming in that describe journal articles, books, book chapters, conference proceedings, and so on. So when we do the smart expansion step, we're also bouncing the data off of central discovery. So if you're looking at the faculty activity reporting tool, for example, you know the data is near 100% complete. And when you take that, bounce it off of the central discovery index, what you can return back to the institution is excellent metadata and links to full text and free to read versions back to the institutional repository for targeting for deposits or as good quality metadata to include, and then back to those expert finder systems as well. So then we put this all together into a research information management solution where we have direct and mediated deposits alongside of our smart harvesting AI, put it all in a research information hub, and then engage in a number of use cases that we'll show you how the data gets in there first, and then we'll get into some of the practical use cases, such as expert finding, completing assessment exercises, having an open access repository, and keeping all this up to date. So the smart harvesting, the main topic today, is finding what you don't already know about authors and their publications, and finding new assets so that the ongoing data entry burden is reduced. And the faculty activity reporting tool was a source into the migration, but it can actually be a recipient of the data back. So if you, instead of making the end user type in the data, retrieve it automatically on their behalf and have it ready for them when it comes time of year to complete the annual activity report, then you can have the faculty member as your ally instead of your enemy in terms of forced data entry. And what we see this playing out in our client universities. So universities that have switched on and started using their smart harvesting have increased their IR coverage by greater than a factor of 5. So you see over time here, the blue line is the number of researchers, the orange line is the number of assets. And you see both on an increasing trend and the number of assets accelerating quite a bit since we had our release of smart harvesting early in 2021. So if you can't quite make out the numbers, that's the last quarter of the graph or so, you'll see a pretty good uptick. And that's increasing more rapidly than the number of researchers, which means the number of assets per person, i.e. the completeness of the database is also on the way up. So we're going to look at smart harvesting in detail here. And the basis of the system is that there are rich relationships between authors, work, grants, journals that were published in, institutional affiliations, and on in terms of data types that are out there. And we're going to look at those relationships in the metadata that we have about a researcher and that we have about an asset, and then use machine learning to make some conclusions about how we would grade the matches between different facets according to name, institutional affiliation, terminology and subject matter, co-authorship relationships, and those sorts of factors that can be fed into the machine learning algorithm in order to apply a grade to a particular asset to decide if it probably does or does not belong to a particular author, and then offer that up to the database. And you can get to a certain point using rule-based methods. So the sort of linear or quadratic along the bottom there might be examples of rules you could apply in terms of author last name and first initial, institutional affiliation, and maybe co-authorship patterns. But eventually the problem gets complex, and the neural net, as employed by the machine learning, can apply a better understanding of how the mix of co-authors, publication venue, subject matter actually translates into a probability that a given asset belongs to an author or not. So then after many training examples are provided, the machine learns where the cutoff should be. So in terms of what feeds into that, we've got researcher data, so initial setup during implementation and then ongoing learning and updates. We've got our central discovery that's indexed and feeding information in. And then we have the pre-labeled data from the university. So what does the institution know about existing work? And then it's run through the algorithm, calculating the features, training the model, and producing predictions as to whether an asset belongs to a particular author or not, according to name features, text features, and general features. Excuse me. So what we're going to look at in terms of features are the name. So here we've got some challenges in terms of last name. First initial is very common, but of course there are variants to names, different numbers of initials recorded, sometimes errors made in the data. So we compare names based on similarity and whether or not the exact or partial initials are present, considering some nicknames, name frequency, interchange, and variations. Then we look at the text features. So how close are two abstracts or titles or journal names in terms of the terminology represented. And this is done by grouping semantically close words. So the meaning aligns their presence in space, and then calculating the difference, the distance between them. And then deciding via some indices that we have, either coming from Google or our own custom embeddings from abstracts, how much the terms overlap and what that means for distance, to analyze whether the subject matter is indeed the same. And then general features. So does this match institution, country, discipline, date, etc. And here's an example of date. So the machine will apply an understanding of what the intersection of the different factors mean in terms of how distant the date of the article is from today. And then the automated capture process runs. So the Esploro application will query the central discovery index, which will return the candidate assets and return those to the system. Those are deduplicated. So there's a decision here. Does at least after it's deduplicated, at least one of the authors has to match an existing affiliated researcher in the institution to be of interest to adding it, because you want to add it to an active researcher's profile. And then it goes through a matching process. So we know it belongs to an author. It comes into the system and is assessed. So does it match with an existing asset? If so, should it be automatically merged into that asset? Or should it be set aside just in case it's ambiguous? Or if it is a brand new asset coming in, can we confirm that it belongs to a particular author? And then approval at that step can be automatic, i.e. that's based on that scoring in the metadata and the machine learning application to the criteria that you saw. Or if it's a little bit less certain, that can also be sent to a manual matching process. So now we're going to transition a little bit and look at the actual user experience, and we're going to go to Sarah to walk us through that. Sarah, you're still on mute.
Thank you. Thank you, Jeff. So Jeff did a great job of walking through the kind of conceptual idea of the smart harvesting process. We also wanted to take a few minutes today to walk you through the practical, so you could see what this process actually looks like when you're running it. What I've done is we've switched into the browser and I have logged into the Esploro administrative user interface. I'm logged in here as an administrator. Everything in Esploro we have designed to be a fairly efficient and streamlined workflow, and that includes running that smart harvesting process. So I'm going to skip the steps of showing you adding a researcher and creating a set, but essentially at the beginning of this process, your researchers would have been added to the system as researchers per user role. And then you can go ahead as an admin and you can manage a set of researchers. So you create the set of researchers for whom you'd like to run through the smart harvesting. At that point, running the smart harvesting is fairly straightforward. Under this repository menu item on the left-hand side, we have our smart harvesting options here. And if I go to those profiles, for the time being, I have the option to run the smart harvesting against, as Jeff mentioned, our central discovery index. All I'm going to do is select the set of researchers I would like to run. Earlier, I ran an example for myself, and then I can click that Run Now job. A couple of things that I wanted to point out in terms of the process of running the smart harvesting. Jeff did a really nice job of talking about how the algorithm goes through and looks at or assesses the probability that a candidate asset belongs to a researcher at your institution. While in the results, we don't see the specific numerical calculation that's applied, what we do see is a ranking of very strong, strong, or uncertain. So every candidate asset that is returned for that author matching task is assigned one of those ranks. When you're running that smart harvesting job, you have the option to determine based on that rank if you have a preference for those candidate assets to be automatically approved, or if you want them to go into the Esploro admin user interface for manual review and approval. So in this case, I could find that I'm very confident in those candidate assets that come in as strong or very strong, and I just want them to be automatically approved. But anything coming in as uncertain, I would like to go through manual review. You also have the option to suppress that automatic approval for specific asset types. So for example, you may not want journal articles to be automatically approved for some reason, and so you could suppress that automatic approval for that specific type. At this point, if I was going to run the smart harvesting, I would simply click run now. The system works behind the scenes to go out and query the CDI and return those candidate assets. Instead of watching a wheel spin, what I want to do is actually now transition to show you what the results look like when they come in terms of that author matching approval task list. So Jeff had mentioned there's a deduplication process for those candidate assets. Once they make it into the Esploro user interface here, what we're looking at is the author matching approval task list. Now I am going to show you the results for an actual researcher. I have done my best to de-identify the researcher because we do want to use somebody who is actively researching, so they're coming from another institution here in the US. But before I jump into looking at those specific results, what I'm looking at now is the overall author matching approval task list for all of the smart harvesting jobs that have been run for essentially Esploro University, our demo site. I will just point out that for any of these assets that have come in, again, to this right-hand side, you see their status and their rank. So did this come in as very strong? Was it automatically approved, manually approved, or is it pending approval? I am going to go down and pull up specifically the researcher name for who I ran this for because I was attempting to de-identify some of this work. She is actually in under just Jane Smith, but her name is not actually Jane Smith. But for the purposes of the presentation, we're talking about Jane. So I ran Jane through the smart harvesting job. Essentially, I provided the system some basic information about her research interests, key terms, potentially some co-authors if that was relevant. And what we're seeing here is the list of results that came in. If we look to the side on the rank, we can see that there were 58 assets that came in ranked as very strong, 4 that came in as strong, and 4 that came in as uncertain. Again, we can look at that status to see whether it was automatically approved or something that I wanted to go through and review and approve. It is important to us that an administrator or staff member would be able to easily make that decision to approve or reject a candidate asset based on the information that is visible in this author matching approval task list. So as the admin, I do not need to go in to edit the asset and view all of the information that has been brought in, all of the metadata for that specific publication, but instead I could take a quick view of the information here and select one or multiple assets to either reject or to approve. Just quickly, as we open one of the assets here, you can see the metadata that is coming in with this asset specifically. Again, that smart harvesting is bringing in the metadata, potentially a link if it's available, but not bringing in the actual full file access. Now, I'm showing you the list of results that came in for Jane Smith, but I don't want to say just believe me that these were the assets that were relevant to her. I'm sure you'd like to know, are you actually capturing the majority of her work? What's the quality of the results that you're bringing in? So what I've done is exported that list of assets, the 66 assets that came in through the smart harvesting job for Jane Smith. And what you're seeing here in column B is an indicator of whether this asset was captured by the Esploro smart harvesting job. And then in column C, if that is a verified asset belonging to Jane Smith. To verify it, I look at her resume or at her Google Scholar profile, whatever sources I can use to verify that this asset does correctly belong to her, and to identify any assets that the smart harvesting job might have missed. I've also sorted these by published year. One element that I think is important to point out is that one of the value adds here for the smart harvesting is the ability to capture content as it's being produced. So Jeff made an excellent point that when it comes to things like faculty review systems, when faculty are at the point of review or promotion and tenure, then those systems are up to date. But often outside of those periods, faculty aren't really updating them. With the smart harvesting, with an initial run, it can be comprehensive and really going through the history of somebody's full career. So what we're seeing here is that for Jane Smith, it goes back almost 30 years, capturing all of the work for her here. But this smart harvesting job then can actually be run as an ongoing job every week. So that the smart harvesting job can say, we last looked for Jane Smith's articles on July 20th. And so next week it's going to look again to see if she has produced anything new. So it's keeping this repository and this research information hub truly up to date. And again, automating that work so it's not dependent on a researcher to manually deposit or an administrator to be tracking down CVs and publications from researchers. If we scroll down here, just a couple of elements that I wanted to highlight. We do see that the smart harvesting captured a range of different assets for Jane: journal articles, book chapters, books, conference proceedings, and even a couple of reports, again, spanning that 30-year time span. And while Esploro is not capturing 100% of her assets, there were a few items that I found via her CV or other sources that didn't come in. In sum, when we look at the total number of assets that I could find belonging to Jane, which was 66, and that's counting only the books, journal articles, and book chapters, as the reports and conference proceedings are slightly less comprehensive in the CDI. But across those three assets in the dominant form of her research, Esploro Smart Harvesting captured 90% of that content. It captured all of her books. There were 2. It captured, I think, all but 1 or 2 of her journal articles. And while that 45% on book chapters might give you pause, it captured 4 out of 9 book chapters. And in fact, 2 of the chapters it missed were chapters she wrote in an edited book, and we did have the book. So it's always important to think of those percentages relative to the actual total amount. So overall, for Jane, as the University of Esploro, I now have data capturing 90% just automatically of her output. Very easy and efficient for me to add that extra, 7 assets for her that smart harvesting had missed. And so now in terms of the data that I have for Jane and running those metrics and analytics, I actually have all of her representative publication across those books, journal articles, and book chapters. And then additionally, some of her conference proceedings and reports. The nice part of this is not only do I have that data in the Esploro user interface, but as Jeff mentioned, part of this is also about being able to update those researcher profiles automatically for expertise discovery. And so if I go to Jane's profile here, I see that I do have all of her work also represented here on her profile, in addition to in the repository. And that is an excellent moment to transition into talking a bit about some more of the use cases for this data once you have it following that smart harvesting job.
So I'm going to go through a bit more of the, what can I do with this information? I've spent the effort to get my people into a database, bounce the information that we have against a source to improve it, improve the coverage percentage by going out to the smart harvesting and using the machine learning in order to engage with that. And then what can I do once I put all this information together? And the most common use cases that we observe is typically for the groups of affiliated and non-affiliated researchers. So these are your constituency of people in the institution you work at, but also going out to the public, students, and mirroring that prospective students, and then staff who need research information in order to complete a particular function, like matching a funding opportunity to people or checking out how much work that might be going on in that particular subject area. For all those use cases, it breaks down into discovery. So finding work and being found, such as collecting the work, publishing it outward to other services, search engines that may index the work. And that's a benefit to both the finder and the scholar whose work is being found. And then expert finding. So rather than looking for the work itself, finding experts by subject matter. And that could be of use to a researcher seeking a collaborator. And of course, use to the researcher who is found and might be invited to join a project, join a symposium. Students seeking mentors, staff trying to identify who on campus does what. Media relations offices that might need to put faculty members up for interviews, keep attention, keep the university and the public attention. So there's a variety of use cases for both affiliated and non-affiliated persons in terms of finding the work and finding the people. And then more typical for the administration, there are also layers of reporting and analysis that are possible. So you can complete reports and analyses that might not otherwise be possible if there wasn't productivity data in terms of publication output, publications in prestigious journals, publication work, grants, projects, etc., that are in a particular subject matter. And then along the way, that's why it's in parentheses there, you can also avoid the manual data entry. So you can use it to fill in activity reporting and analyze the work of the faculty. So we've got a growing community of users worldwide, and most of their logos are represented here. And I'm going to turn it back over to Sarah to walk us through some of the practical use cases. So you've seen, this is sort of the theoretical presentation of what can I do with it, and then we're going to go look at what some actual institutions are doing.
All right, so as Jeff said, we wanted to share a little bit about what some of our current customers, actual institutions, are doing with Esploro generally and with their smart harvesting specifically. So he had emphasized the value of discovery with smart harvesting. Of course, most institutions would like their scholarship to be discoverable, and in order for that to happen, first they have to have it, and then they have to have a tool to make it discoverable, and that's what Esploro supports. So the first example that I wanted to start with was actually talking about the University of Iowa. The University of Iowa was one of our first development partners, and they were in fact the first institution to engage with and begin using our smart harvesting process. This was about a year ago that they began last summer, and they were nice enough to share with us some very specific examples. This was, of course, at the height of COVID, with many people doing research in that topic. So they were particularly interested in ensuring that their researchers' work that would be related to that area of study was discoverable. So what you're looking at here is actually the Esploro repository for the University of Iowa. I have gone in and searched specifically under the advanced search options for one of their researchers, Dr. Perencevic. And I specifically did this because they gave us some nice information when they were selecting the researchers that they wanted to run through smart harvesting at the time. Those people whose work they really wanted to ensure was discoverable and accessible by both internal and external users. Eli was one of the people that they ran. In their existing repository that they had prior to Esploro, they reported that they had 8 assets for this researcher, 8. After the smart harvesting run, they had 191 assets for this researcher. That was a year ago. And you can see that today there's 245 journal articles alone for this researcher, in addition to these book chapters, editorials, and other asset types. So immediately the University of Iowa was able to see the benefit of the smart harvesting and being able to capture what had previously been only 8 assets for this prolific researcher to almost 200 assets for this researcher, and somebody who was likely to be very relevant, especially to what was happening at the time. Just to mention a second example that they provided us, another researcher who was doing work relevant to this area of study that in the existing repository had 38 assets, and after the smart harvesting had 259. So we can see that for a lot of these researchers, particularly when we are talking about that institutional repository, there can be quite a large gap between the amount of scholarship they have produced and what is actually captured in that repository. And smart harvesting helps to fill in those gaps. A second customer use case that I wanted to provide here was actually with Rutgers University. So one of the driving factors for Rutgers to select Esploro was that they have a very strict open access mandate. Any journal articles that their faculty publish are required to be in their repository and openly available. At the time, they were struggling to find efficient workflows to even support that, to identify the articles that faculty had published, and then to try to identify the articles that didn't have files available that they needed to reach out to the researcher to provide. So here you're looking at the landing page for Rutgers. They have branded it SOAR, the scholarly open access at Rutgers. And just to show you an example here, I've gone ahead and done a search for one of the assets that they're looking at. And so I've just pulled this up. As you can see for this article, they do have an accepted manuscript version, a PDF that I, as an external member, can actually access, as well as links that I can access here. And if I were to click on that PDF link, I do now have access to this full publication, which I could then download. There are multiple elements of Esploro that were beneficial to Rutgers in their efforts to try to support their open access initiatives, including not only that Esploro can both host the assets as well as the files attached, but that Esploro is agnostic to file type, so that while it's important and obviously the mandate covers having those PDFs of publications, there are of course other types of scholarships that their researchers would like to have represented, discoverable, and available. So with Esploro being agnostic to file type, all of that can be supported in a single system. The other piece of this is that through the smart harvesting, they can now automatically capture records of the publications their researchers have produced, so no longer needing to chase down that information from the scholars themselves. And then they can run a simple report that says, show us all the journal articles in the repository that don't have a file attached. So they can be looking at something like this report here, where now they have a short list of publications and affiliated researchers that they need to reach out to communicate with, to ask for that file that they would like to include to meet that open access mandate. So Esploro is not only making their work, helping them to support their open access mandate, but that mandate is in the service of making their work discoverable. So now they have the smart harvesting and the analytics and the workflows to make that a much simpler process for them. The other piece here that Jeff had talked about was that expertise discovery. And I wanted to take a moment to show you a couple of examples of researcher profiles from current institutions. I'm starting here with Brandeis. Brandeis is actually one of our newer customers, still, I think, going through their implementation and building out their profiles. They have actually currently hired 3 student assistants who are going through to do some of that validating of the author matching approval task list from their smart harvesting. So I set that up so that you can understand that Brandeis is not an institution that has had Esploro for 3 years and been working with smart harvesting for 18 months. They really just started this, I think, over this summer in the last couple of months. While I don't have the data to say exactly that all of these assets came through that smart harvesting process, I would be willing to bet that probably there is not a staff member at Brandeis who has spent the last few months manually adding thousands of assets to Esploro, and that in fact, that process of running the smart harvesting has actually touched hundreds of their faculty profiles. So I did a quick search in their repository, found a few people who seemed to have a number of publications and went to their profiles. And in fact, you can see here for Dr. Martyr, who's in the biology department, that for her relatively new Esploro profile, there are already 320 assets listed on that, almost 300 journal articles alone. Same for Dr. Harder, who's in their basic medical sciences program. Again, over 300 scholarly assets showing on his public profile, including almost 300 journal articles. Without a doubt, I believe that much of that is probably the result of the smart harvesting work that they have been doing over the last couple of months. To show you a couple examples of one example of a non-STEM researcher. Now, this is coming from Southern Cross University in Australia. They have been some of the strongest adopters of Esploro and the profiles really since they began last year. I will emphasize that in this case, Dr. Carriage's work has not been captured through the smart harvesting. As you see, a lot of it is creative work like musical performances and compositions. I did briefly want to show you a profile for a non-STEM researcher who has a lot of creative work, again, to show the value of not only the discovery of that content that's captured through smart harvesting, but also the fact that we have made it a very efficient process for researchers or staff members to deposit other types of scholarship that might not be captured through the smart harvesting right now, so that their work is equally discoverable through Esploro. And to talk just briefly about the expertise discovery, we're still in Southern Cross. We're searching through their profiles right now. When you are searching for an expert at an institution, you can go ahead and type in a key term, or you could look for somebody by name or affiliation. So I'm actually going to look for research on coral reef ecology here at Southern Cross University. Perhaps I'm someone in the media who's looking for an expert quote, or I'm another researcher who's looking for a collaborator. So I can go ahead and search for this. What I want to point out is that it's going to return a number of profile results, and you'll see that for some of them, coral reef ecology, as it does here for Dr. Abrego, appears in the keywords. So not surprising that that profile has been returned. But there are other profiles like we have for Dr. Harrison here, where coral reef ecology doesn't actually appear as one of his key terms. It's important to note that when users are searching for expertise using the Esploro research portal, that query is actually searching not only just the keywords a researcher may select to tag their profile with, but also searching their output, searching their journal articles, searching the grants that they've been awarded, and returning results of those people who are doing work in that area, even if it may not be listed as one of their keywords. That type of a search result is important to ensuring that true expertise across the institution is being discovered. Of course, researchers collaborate with others outside of their main areas of research, but they may still be doing very good work, and they'd want to be discovered for that. At this time, as you saw, there wasn't really context surrounding the search results, but that is something that we are working on and very interested in providing. Why did these researchers appear in this expertise search? Perhaps X% of their publications talk about coral reef ecology. They've received a grant that is specific to studying coral reef ecology, so on and so forth. The last use case that I wanted to mention briefly is in the metrics and analytics. So for this, I'm returning to our administrative user interface because, of course, you're going to be using the analytics here as a staff member or an administrator. And we do use the Oracle Analytics and data visualization tools. The first point that I want to make here is that there is a wide scope of data that is available through Esploro as a result of the smart harvesting alone. So in terms of building reports, there are both out-of-the-box reports and reports that you can build yourself. What I want to point out is that when we are looking at something like our dashboard here, there are 6 different dedicated subject areas to data in Esploro. So there is a subject area for the data that's come in related to that smart harvesting job, but also to the grant information that's available in Esploro, the assets themselves, how those assets are being used, and then of course the researchers as well. I've opened just one of those subject areas here. This is the Esploro Research Assets subject area. And what I want to point out is that this is one of the 6 subject areas. And if we scroll through it, there are almost 35 different subfolders underneath that individual subject area. And if we open one of those subfolders like the asset details, there's a huge number of data fields here, and you can use all of this to construct those reports. So this is just one subject area, meaning that you have essentially hundreds of data fields to work with to start to build the reports that are important or valuable to you. I want to move into just looking at the dashboard here very quickly so you can get a feel for some of the out-of-the-box reports that we have created. So when we are looking at something like just basic information, it's easy to run a report that shows something like how many assets do we have in the repository. So what I've done is build a report and actually exported this here so that we could take a quick look at it. So you can imagine something like accreditation, reporting, end of year scholarly celebrations. Often one of the first questions that someone needs to answer is how much scholarship was produced this year and across which asset types and which departments and which researchers. With all of that data in Esploro, it's now very easy to produce a report like that, either at the level of the researcher, an academic unit, or the institution broadly. In this case, what I've done is run essentially a 3-year review report for scholarship that's been produced by a specific department, in this case, the Department of Psychology. And you can see that I've been able to break out how many assets are in the repository, what year they were produced, and the different asset types. I can also then expand that to see exactly what were these titles, who was the affiliated author of each of those publications or scholarly assets. And of course, this is also then included with the data visualization. So instead of just producing a report like a table, I can also produce great data visualization options that we're seeing here. To look at those data visualization tools in just a bit more detail, I want to go ahead and switch into, open it up here, switch into some of the data visualization options that we have. So I'd run a couple of reports just looking at the results of the smart harvesting. Again, able to export these all as a table so I can see the number of approved assets and across the different departments where those are relevant. And then also, and excuse me, I just have to move my window here for a minute so I can actually get to it. But then also being able to look at those data visualization tools. So with the data visualization tools, you really have a plethora of tools at your fingertips to start to build very interesting and engaging data visualization. So we can go back to someone like Jane Smith, the researcher who I ran through the smart harvesting. And I can run a report like you're seeing here where I am looking at her number of assets, the year they were published, and the asset type. And so you can see that I've been able to break this out by color coded. And this is interesting because not only do I have valuable information about her level of productivity across time, but more broadly, I could be interested in looking at patterns of productivity across the researchers at my institution. This might be the kind of data that would be relevant to somebody in a research office or in a provost office. As Jeff had mentioned, once you have all of those research assets captured by the smart harvesting, you are also able to connect them to grant data or to build relationships between those research assets. So I can go ahead and look here to see not only what are the various assets that our researchers have produced either over time or within a specific time period, but also what does it look like for those relationships between them. So if I look here at my asset relationships, I can see how many data sets are linked to a publication, how many publications are linked to a conference presentation, and I can really see that entire network of relationship assets. Similarly, if I wanted to look at this from the grant perspective, I could also see for the grants that have been received, how many assets are connected to those grants. This is particularly valuable to institutions that might be providing things like seed grants to their researchers, where they are particularly interested in knowing we've invested in our researchers' work, what has been the outcome of that investment. So in this case, I can see which assets are related to grants, and I can also see are there types of assets beyond the traditional article that are being supported by grant funding at our institution. Again, there's a huge number of data fields available in the analytics that you can use to build and run your own reports to support multiple stakeholders across campus, both the library's needs as well as those in areas like the research office, sponsored programs, or the provost's office. So those are some live customer examples focused on the discovery, the expertise, and the analytics. And with that, that was everything we had wanted to show and discuss today. So we're going to open it up to Q&A.
Excellent. So this is Mark jumping back in here, looking at our Q&A module. We have several questions already in the hopper. I would encourage folks, if you do have a question that has occurred to you throughout that you haven't yet dropped in there, take a second just to do that. And I'll start moving through them right now. So we have a question that came in a bit earlier from Laura, who asks, do these profiles in Esploro integrate with Orcid profiles? Many people already have Orcid profiles in those auto update. And then how does the smart harvesting process integrate with other profiling systems? She says such as Esploro, but are there other systems that it does integrate with?
I'll answer the first part about Orcid, and I'll let Jeff jump in and answer the second part. So yes, there is integration with Orcid. So researchers can add their Orcid ID to their Esploro profile. And by early next year, this will be bi-directional integration. So the first step will be that we can actually import the data directly from the Orcid profile to update the Esploro profile. And by early next year, actually, we'll be able to update the Orcid profile with information from the Esploro profile. That's particularly relevant because of the smart harvesting, that we may actually be capturing scholarship and assets that it's then worthwhile to add to that Orcid ID or to the Orcid profile.
And adding to what Sarah just said, we're hearing from institutions that that's a value that they're looking to provide to their constituent faculty in terms of, we want to automate as much as possible, but in terms of really polishing a profile with those final assets and updating it with other types of information, the incentive is to add it once to one system, push to Orcid, and then have that profile be portable with you at whatever institution you end up at. And then I think the rest of the question, we don't consider the data that we're gathering, bringing to be proprietary to us in any way. So there are APIs to obtain the data and integrate with other systems. There's open documentation. It's either developer or developers.xlibrisgroup.com. I forget which, but that's all open. And basically you can retrieve the people, the assets, all kinds of metadata about both. And there's also deposit by asset as well, if you've got resources coming in from other places. So we try to be just as open as possible about data synchronization, both in and out.
Excellent, excellent. So we have another question here from Laura, who says, do you have plans for faculty to be able to spin off a CV from this, as that's the sort of thing, the sort of request that they frequently get there? And I see you nodding, Jeff. Do you want to jump on that one?
Yep. Just making sure I'm unmuted. Yeah, that's another thing. We have an extensive public roadmap as well out there on our knowledge site. So, that's out there, and CV is certainly on that as well. The key is gathering all the information together that will let you produce a good CV. The publications are probably the second easiest after grants, because those are really well captured in proposal routing and approval systems, because they're tracing money and people and space and those sorts of things. So you get the projects, you get the publications data, and then it gets a bit trickier in terms of other creative works, as Sarah showed about gathering up those other types of assets and productivity. And Maybe the institution has a faculty activity reporting database, maybe they don't. And review has happened at the department or school or college level before, and that hasn't been centralized. So there's a tough part there in terms of getting people's full work histories, historical affiliations, and educational background, and a few various other things that really make a CV that they could, run with. So if the institutional commitment to get those additional bits of data is there, the CV generation is definitely on our roadmap as well. Yeah, we've heard that request from elsewhere.
Excellent. Very interesting. Thinking about the accessibility of all these different sorts of data. So we've got a question here from Barbie who asks, and maybe this is something you can or can't talk about, I'm not sure. Barbie asked, will you be expanding the detail in the tool by including where researchers' work has been cited using something like Clarivate Research or other tools to determine impact? Is that something that's also on that roadmap or something you've been thinking about?
Yeah, the ability to include metrics is there to a degree right now. In some of the profiles that Sarah was flashing up on the screen, you might have seen the altmetric donut in there. And then depending on where you are as the viewer, you might see a Clarivate time cited count already integrated if you were a subscriber to at least a basic level 2 Web of Science. So you might see some of that in there already. We definitely hear requests to analyze the citation data in bulk. That's on the roadmap. The providers of that data consider it to be quite proprietary. And of course, the Clarivate acquisition of ProQuest and Ex Libris brings us all under one roof with Web of Science citations and impact factor calculations, and puts us in a more competitive position versus Elsevier, and probably also versus Digital Science Dimensions as well, where Google Scholar, another key source that people tend to like because of its inclusiveness in the numbers, is sort of often a different bucket, that the individual records are accessible, but it's not used in bulk format, for analytical or evaluation purposes. So that's kind of the lay of the land. I mean, we're merging with Clarivate for anybody who hadn't heard the news, but if you work in a library, there's a good chance you did. So I think it would be, I don't have any special knowledge about how exactly things will be integrated, and there are certain restrictions that we've had to abide by as Clarivate is a publicly traded company, but I think it would be silly to think that Web of Science citations would not end up playing a role in the analytics.
Very interesting. Excellent. Thank you. We've got several more questions that have come in, and looking at the time, we have just a couple of minutes here left in the hour. So one of, and maybe, so maybe we'll take this question here from Marja, and I apologize if I've mispronounced your name, who says, did I understand correctly that you merge duplicate records? And if you do that, do you prioritize some records as originals or that sort of thing over others representing the same asset? How is that deduplication handled?
but Sarah might want to chime in on this one too. There's deduplication on a few different levels. So the first is our central discovery database is pulling in records from aggregators, from thousands of publishers. So there's all kinds of duplicate records coming in from all over in that respect. So those need to be deduplicated against each other. And then when they form a record, we've got our external view of the institution's scholarly works, and then the institution supplies its own. And often with poor metadata, without DOI being enforced as a field or checked for accuracy. So we need to take those kind of lower metadata quality items, typically lower metadata quality, bounce that off of our central discovery, and then in that way, that's sort of a deduplication by checking if that asset already exists, and then bringing in the preferred metadata, and then supposing and then part of deduplication is avoiding duplicates in the first place. So there's also a check for other affiliated authors in the institution, so you don't end up with multiplicative importing of assets. And then once you do have duplicate assets in the system, the check there would be, do we have things with the same DOI, same title, those sorts of things. So that's the, hopefully we've avoided deduplication by some of the steps earlier in the process. Sarah, I don't know if you wanted to say anything there about like workflow or what it looks like.
No, I think that's right. And Jeff, correct me if I'm wrong, but on our roadmap, I believe for next year is the process of being able to merge data. If, for example, Smart Harvesting captures an asset for which is already in the repository, but the record from the CDI has more metadata in it, for example. And I believe that's on the roadmap for next year.
Yeah, because the data from CDI is sort of as supplied by publisher or as indexed in the aggregation database. The model so far has been sort of king of the hill. The better record just knocks the other one off the hill. Where there is also a concept of a super record that exists in the industry, and that's taking the best metadata from each. Of course, you could edit what's in the database to accomplish that, but the ability to put them together in the simplest way possible on the interface is also a plus.
Excellent. All right. So looking at the time, we have a few more questions hanging out in the Q&A, but we've already gone just a little bit over. So we apologize for, of course, not being able to get to all of those questions. But before we sign out, I would be remiss if I didn't take a moment to say thank you to you, Jeff, and to you, Sarah, for walking us through this tool and all of the possibilities that it opens up, and the things that we can learn. So thank you for that. And I would also remind folks listening in out there that we did record the session, so be on the lookout for that follow-up email with a link to the recording. And if you have just a couple of minutes to fill out a very brief survey as you sign out, that should pop up in the browser window for you. If you could give us just any responses that you have, we would really appreciate that. Thank you to all of you out there for joining us today. We hope you enjoyed the session, and of course we would invite you to our upcoming webinars. I hope to see you in the future. Thanks very much.